Good morning, everyone. My name is Rick Huang. I would like to welcome you to join this exciting panel discussion where we delve into the interwoven themes of artificial intelligence and formal engineering. And I would like to extend my gratitude to our esteemed panelists from Sandeep Jana from Synopsys, and Qilai Huang from Siemens EDA, and Chris Comer from Cadence. We are truly honored to have such distinguished panelists joining us today. And as we know, the era of AI is coming. As we stand on the brink of technological innovation driven by AI advancements, I think it's very essential for us to rethink about how AI can reshape the formal engineering. At the same time, as AI systems integrate more and more hardware into their system, their designs, it's also very crucial to leverage the rigor technologies of formal methods into the design process. Therefore, we are going to explore two essential questions, today. So the first is, how is AI improving the formal engineering? And the second is, how are technologies from formal engineering being employed in the verification process of AI chip designs? So throughout this channel, I believe you will see that this powerful symbiosis presents a powerful, great opportunity for the collaboration between AI and the formal engineer. And yet, as we embrace these innovations, we must be consider the challenges of this they bring. So as we move through this discussion, I would like to encourage you to think about the implications of these advancements. For example, like what does the collaboration between AI and the formal methods look like? And how do we ensure that the rapid pace of AI innovation doesn't compromise the engineering quality, and perhaps most importantly, what insights and future directions can we draw from the intersecting fields? Okay, so let's open the floor and engage in an interesting dialogue on the fascinating convergence of AI and the formal engineering. Okay. So let's open with the first question. So given we have the experts from the major EDA vendors, Synopsys, Siemens, and Cadence, could you share with the audience some formal and/or verification tools that incorporate AI techniques? And additionally, how does this tool differ from the traditional verification methods? So maybe Sandeep, you want to go first?
Thanks. Verification and debug takes up a significant amount of time and are arguably one of the most challenging part of chip development. As designs become increasingly more complex and move down the nanometer scale, this problem gets more compounded. And adding to the dilemma is the shrinking of market windows. So verification tools and technology must keep pace with this demand while generating high quality of results, faster time to results, as well as reduced cost of results. And AI has been making a significant contribution in this area in the domain of EDA. Like machine learning algorithms can review large variety of data, including layout and performance parameters, in order to generate highly optimized designs. AI has also been making significant impact in design verification too, by ensuring functional correctness of large and complex designs. Like AI techniques such as data-driven invariant learning and symbolic reasoning, right, are used today in order to review design specification and to ensure that there are no potential errors over there. Machine learning algorithms can review very complex data, thereby finding correlation and pattern which otherwise would have been extremely difficult to detect otherwise. So this AI-driven verification tools enhance the verification process, reducing design errors and at the same time of reducing the risk of silicon bugs. So I'll talk about a few tools from Synopsys which has been working in this area. Like the Synopsys.ai is a well-known AI-powered full-stack EDA design suite which facilitates the overall design phase starting from architecture through sign-off. And VC Formal product, which is part of the Synopsys.ai suite, so leverages AI and ML techniques in order to enhance formal engine usage. So formal verification, in essence, is a search problem, right? And in this space, when there's like a lot of non-determinism, where we don't know exactly what is the best way to tackle a problem, so this is a space where AI or ML can play a potential role.
Okay.
For example, today, when we are solving, say, like thousands of properties formally, under the hood, we are using several algorithms which are captured in terms of formal engines. Each of these algorithms have different kinds of parameters which can be tuned, and we would want to try almost all of them in a systematic manner. So the mapping of properties to engines, and then from the engines to the parameters. So this is one such search space which is pretty amenable for AI and ML techniques. And VC Formal's AI-powered orchestration strategy and the smart engine selection works in this area, where we use techniques like reinforcement learning in order to improve the overall convergence. It also uses on-the-fly machine learning so that when the properties are being processed, that information can be used in subsequent actions. So the decision taken on each property are stored, and in subsequent regressions, they are leveraged so that it becomes much more faster. And yeah, I think this is one area which has made a lot of impact, because here it learns information from the previous phases and uses them in the next phases. And it has been a game changer for our users, as there are like a lot of interactive formal verification usage today in the industry. I would like to conclude by talking about the contribution of AI in coverage closure as well, or verification. Like the VSO.ai, which is Synopsys' AI-driven verification solution, which helps the verification teams to achieve coverage closure as quickly and as cheaply as possible while generating like high quality of results. AI techniques are used in order to identify and reduce redundancy in the regression, do automated root cause analysis of coverage, then infer coverage from the RTL and the stimuli to identify coverage gaps, and thereby providing guidance to the users, right? So in summary, I would say that AI and ML has been making significant inroads in the context of formal as well as verification in general. And I think this is one space which is expected to grow in the coming days.
Wow, very impressive. So you've been using AI in almost many tools. Yeah, wow. So maybe Chilai or Chris, you want? Chilai? Yeah, okay. You want to share your experience from Siemens?
Yeah, okay. I think we have been kind of, actually really, we have used AI for some part successfully. Just like I mentioned about the VIQ part, like coverage, all this part. And we are also trying to use like ChatGPT for other one. For example, one thing we are trying to invest in right now to do the customer support. Because customer support, you can think it's a very natural, for the kind of things, the ChatGPT one there. But even that one requires lots of the, you can say, refinement right now. So it's not, you cannot just take ChatGPT so you can use it right away. Because, for example, we have lots of the customer sensitive data, which you cannot leak out So now, just even a simple thing like that is how do you filter those out there? So we are doing some of those parts with some of the AI startup company working on this customer support, because support is always the difficult problem.
True.
We all have this problem. And we all complain about this part, right? Because you call customer support, they don't understand what you're talking about. So we hope this is the part we are investigating. And we also have lots of the information there, but how do we teach AI to do? So this is, unfortunately, it's a very difficult problem here right now. So this will be one thing there. And another part, like we are, I'm not very familiar with the formal part because
That's okay.
in Siemens, there's a separate group there.
Yeah, we are talking about general
I
verification.
only do respond for the verification part there. So then verification, we have several other projects we are also working on there. Besides the VIQ, just like talk about, like when we run the regression, because we need to provide the information for the reduce the learning, trying to narrow down the things.
Regression.
Yeah, but still, currently requires some kind of, you can say, convert information to the format suitable for that tool there, IQ. Ideal cases, we really want to derive those information from system Verilog. Fortunately, that's a very difficult problem also.
Yeah.
So for example, I know one part of the formula is people are trying to do is from generate the assertions from the spec. Fortunately, because people are talking about SVA, system Verilog assertion, but most of the assertions is difficult to describe in SVA. You need to have a thing like the BFN there than to have. That's a part that we are working on very closely.
Okay. Yeah, I think the AI generated assertion should be a very interesting area. Maybe Chris, or you have a similar experience?
I can touch on that. So first, thanks for having me here, and first time in Taiwan, and enjoying it very much. Thank you.
Great, welcome.
So I manage the product engineering team for Jasper, so the entire platform of Jasper and formal verification. So I come from a very formal verification background. In fact, Rick and myself were at Verplex at the same time many years ago. Your hair is not as gray as mine. But I will say, in being invited to this panel, the first use of AI and ML was to generate my bio, which wasn't put up, but it's in the program, I assume. So there's just tremendous use and capability of this technology. And by the way, in giving a prompt of some bullet points for it to create a bio for myself, I like GPT-4 the best. Llama didn't do as well, so just a side note. But in terms of how we're approaching formal verification and AI, some of the points that were made are very valid. But I think if you abstract it, what we're trying to do is solve some of the most difficult problems people are facing when running formal. So the question was asked earlier when Eric was speaking, I have undetermined, what do I do? How can I measure that? Things like this. So a lot of the energy is being spent on performance and things like this. And like Sandeep said, the engine orchestration and removing that need for the user to figure out what engines on what properties, and so very much you can use an orchestration and reinforcement learning to help the user get maximum results without having to really know the details of the engines and selections and things like this. So this has been very powerful and been in the tool for 6 years or so. So this is one area. So we're really trying to target what are the most painful points of formal that can help people achieve better results. Other area that we've been applying this to successfully is around lint. So as part of our Jasper platform, we also have a super lint tool, which goes beyond just structural lint. It actually does some auto-formal generation from structures in the RTL and generates properties for them. And with that, as everyone is familiar with, lint can be quite noisy. So we're trying to look at ways and build using ML to figure out what is really noise and what is not noise based upon supervised learning and what has happened in the past and things like this. So really it's about applying it to high value problems in the space of formal, and that's what we're doing. Now, moving on to your point, Rick, you're asking about, SVA generation. So this is the next area that's we're looking into this as well. It's kind of the dream, right? I just want to write some natural language and see what, can I write assertions from this way? Has anyone tried to use some sort of generative AI to ask a question and see if you can get SVA from it? No one?
Yeah.
I have many times. But I'll talk about that maybe in a future topic, but this is absolutely in our near-term radar, but it's really trying to figure out what is possible today. But this is absolutely part of our near-term, and I'll talk more about it, I think, in some of the later questions.
Okay, cool. Yeah, I think it's great to hear that all the EDA vendors are working on the tools that utilize AIs. But I believe you must be very eager to using it right now, right? But since these tools are relatively new to the IC design industry, I think there must be some important do's and don'ts that when using the tool. So would you recommend the best way to utilize the AI power tool, or do you see any challenges or opportunity that lies ahead? Anyone want to share first?
I could,
yeah.
Maybe I'll start.
Please,
so,
please.
Yeah, so there's opportunities and there's challenges. I think the opportunities are infinite. There's no lack of ideas of people wanting to say, oh, can we do this? Can you automate that? Can you make that happen? And so take, for example, something like the SVA generation. Why I asked the question of if you've ever tried to inquire about generating an assertion from natural language. If you look today, I think the models are not well trained in this area, right? So the result you get tends not to be very good, and I've tried a lot of different models. But there are means and ways to improve on that, just even with the existing models. But I think this is the trade-off, is what is possible today, given the models and what they're trained on. How many people in here work for a company that's exposing their RTL and SVA to be trained on? There's no one in this room. And so I think that's part of the challenge that we have as a vendor, is there's sort of this expectation that we can do this very well. But the reality is we have a lot of data, but we're very cautious and sensitive about using it, and we will not use it right now, right? So everyone's trying to navigate this and how to really use data and keep IP, all of this stuff is a big challenge right now. So there's tons of opportunity. We can apply these technologies to SVA creation, making that even grander. You could say, I want to, from spec, generate my whole test bench, formal test bench. That would be tremendous. People have always dreamed about, can I take a UVM test bench and turn it into a formal test bench? I mean, these things are great, but I think they're beyond what is possible today. Things will get better, the models will be improved, but I think the expectations need to be in check, and we really need to understand what is possible today.
Yeah, true. Yeah, so if we look at the GitHub, there are millions or billions of open source software out there, right? So,
yeah.
But for hardware, we don't see many Verilog design there. Yeah. So maybe from the academia side, we should encourage students or researchers to open source their hardware design, so that we'll have a better future and better model. Yeah, so,
yeah, actually, I think we have the AI expert there. They did a survey in the 2023 paper. So he talked about like for example, like open source software. Say how many programs in Verilog or VHDL? It's about 300. 300 to 400. It's very small scale. Wow. So of course, he says, which I should kind of convince or say that everyone put the resource together to have this one, just like image. They have the image in there.
Yeah.
Have a huge number of the image there. I say, well, that's a very difficult one. Trying to convince Siemens or Cadence Synopsys, or even other one like the NVIDIA to donate their RTL designs. That would be very difficult. But on the other hand, I also kind of have a concern there because one way is, yeah, you need to increase your data tremendously, which is very, very difficult. But in another way, I would think about the other ways, trying to kind of have the AI tool understand, like I say, like system value, language syntax is not that complicated. You can face this, then you can build a lot of things with very limited number of the test case. But somebody needs to do those work. You know, I'm too old. Otherwise, you know, I would encourage a PhD student also. This will be a very good research topic to do.
Yeah, maybe some young one from the audience.
Yeah.
You can start a consortium, I mean, for
Yeah.
the open
Oh,
value
and this,
data.
yeah. Because if you are successful, you will be very rich. If you are not successful at this, you will get your PhD.
So Sandy, you want to share?
Right. So in terms of challenges, maybe I'll say that yeah, formal verification is a pretty hard objective in the sense that it can either give us a proof or a counterexample which shows exactly what's the problem. So there is very little scope of error over there, although machine learning paradigm has evolved in a way where it's okay to err as long as statistically it's doing correct most of the time. Like say classifiers are expected to have 99% accuracy, but 99% is not acceptable in case of formal, right? So only 100% is an acceptable criteria. So what do we do in that case? For example, say in things like simulation, when we get 90 to 95% coverage, it gives us confidence that the design is mostly correct, but we don't have that kind of freedom in formal. So realistically, areas where AI or formal can play a significant role is in the phase of, say, the performance improvement, which we already talked about, where there is no ambiguity regarding the yes-no truth. And in terms of the opportunity, I think I'll also like stress upon the same point of the generative AI, which both Chris and Chila had talked about. So as the design complexities increase, there are a couple of important points that are coming to the forefront. For example, navigating to the design and putting the appropriate property in the right place is becoming a humongous task, right? And there are certain components in the design like, say, FIFOs or arbiters or counters, which are generally like very error prone. Now, AI techniques can be used to find out those kind of components, and they can help assist write the right set of properties, which can be put in place over there. Now, in that sense, the GenFV feature of VC Formal is playing an important part. It's creating these properties automatically, and then it also helps in the overall acceleration of the creation of this verification collaterals. And also, once these properties are created, then they can be cross-checked against each other for consistency. And if, say, formal is working along with simulation, then these properties can be compared with the simulation dump to ensure that these are consistent with the design behavior. And also, in a sense, this is helping to democratize formal verification to engineers. For example, today, very few people, or very few set of engineers work in formal, right? Because otherwise, it is supposed to be tough and requires certain level of expertise in order to make an impact over there. Say, being able to translate natural language specification to a language like SVA, it's not very easy all the time because inherently it is ambiguous in nature, and because of this ambiguity, there can be like errors in the human intervention that comes into play over there, right? And also it takes a lot of amount of time in order to master SVA. So that's where if this AI and ML knowledge assistance or regenerative AI like technology can be used, then it can help ramp up the engineers pretty fast so that the conversion from the natural language specification to the formal verification test bench happens like much more faster.
Yeah, just to add to that, I think it's perfectly right. And what we're passionate about doing as formal people is democratizing it further. We want to get it to more people, make it easier to use, and that's where the AI and ML only potentially helps this if we can lower the barrier and deal with performance and create environments more easily. So, I mean, I think there's, from a formal, those of us passionate in formal, we see AI and ML as a huge enabler. It's just, you know, it's not there today. It's going to be used, and we're using it in the most effective places, but can absolutely be used to further democratize and get formal into more people's hands, which I think is what we consistently hear as well. We don't have the people to do formal, but if we can democratize it, lower the barrier through these technologies, it'll be win-win for everybody.
Okay, yeah. Talking about lower the barrier, or I think you may know that in these days in the software, the area, people are talking about the non-code and agent, right? So the AI model can help a software programmer to write programs, be them C++, Python, even JavaScript, TypeScript. But on the Verilog side, I think that's, hopefully that's also a future, but I think there are challenges that we need more people that can contribute their codes or models to the open source area. Okay.
Yes.
Yeah. So I think we have learned about the how AI has been used in either in verification tool in general, and what's the opportunities and challenges out there. So next, I want to move to the next direction, which is about the AI chip design. So I think as I mentioned, there are more and more AI chip design, and I believe the verification problem for the AI chip design is kind of different from the traditional designs, right? So what's your experience in the verification tool used in the AI chip design? Is anyone of you want to share your experience? Or
I think in some way, we access with lots of partners. You know, because when Avery was by itself, we are always joking about, we work with all the IP developer except Cadence and the Synopsys. All the other one working with us. So we know all the startups there. And we joined the Siemens still some way, because those two, they have their own IP company there. So they are competing. But we know with a lot of those, so just like we show all those VIP parts there, because an AI chip, more and more now actually is an AI edge device. Those one, actually you can think about, they have all the peripheral things there, which are covered by our VIP there. So, and they have providing their core part. By the way, some of those core part is not very difficult there. You know, it's matrix multiplication. Well, it's complicated, but normally about two loops or 3 loops, that's all. Normally, I think even the ChatGPT is 7 loops there. Those are, you know, in some ways, very structure-oriented there. So, yeah. So that's a part of, we work with lots of those companies there to help them to verify. Because they worry most actually about all those peripheral, because if peripheral is not working, then their chip still doesn't sell.
yeah, okay. So Chris, you want to share?
Yeah, I would say that you mentioned, I think that the general statement is what's the biggest change with the AI chips, and it's a lot more math. And for those that have been in the formal space a long time, we've always positioned formal verification as something is avoid data transformation. You know, stick with control logic, stick with data transport type functions. Formal does very, very well in these areas, finds those corner case bugs, all those value propositions that you've heard over the years. And so what the AI chips are doing, there's a ton more math. There's this data transformation, you know, math that's happening, dot products everywhere. And now we know why we learned all this linear algebra and matrix multiplication in school, and why I tell my kids why it's important now. But you know, this is where it's really taken off. We're seeing a lot more people now developing these algorithms and things, and a lot of that is done in C. So people will have a C reference model of whatever this algorithm is, and then they need to write, you know, RTL, handwritten RTL, and so there's a lot of need to do equivalency checking between C and RTL. So as the math is increasing, C is increasing, we're seeing this trend, and we were a bit late to the game in the Jasper side on this space, but we've been in it a few years now. But you can really see this, math taking off and pushing formal into, we can't avoid this, and so there's many more engines being developed and are developed to solve these math problems where it's been an area that was avoided before, but no longer is, and we need to keep up with the demand of this math, and that's happening in the chip designs for AI.
Yeah, I think the math module are very challenging for formal verification. But at the same time, I think the verification of AI chip is kind of different from the traditional assertion checking, right? Because if that, for example, is a recommender system or something prediction, you may tolerate some errors, right? So I think there should be some challenge and opportunities there. So maybe Sandy want to share more?
Formal in AI hardware, right, has definitely a lot of challenges, and this is a new emerging area, more so because people are writing function approximators in the AI hardware, right? And this is inevitable because the ML models use functions like trigonometric or transcendental and sigmoid, for which no real finite forms exist, which means that formal engineering has to deal with approximations, errors, right, and asymptotic convergence. So there are new ideas emerging in this area, for sure. Synopsys DPV has been playing a very prominent role in this area for quite a long time, actually, now. And here we can compare like the C model of the hardware with the RTL implementation and stuff. Now, architects today, they can code the latest innovations in design and architecture in C++ and compare it with standard functions and then check it with respect to the RTL implementation. Now, in AI, the data path mostly consists of this math and the floating point operations, which require this kind of approximations, right? So applying formal engineering in that area is definitely a new emerging trend, and to some extent, all the formal tools need to evolve to reach there. And Synopsys on the DPV side has mentioned that we are heavily investing in that area.
Yeah, cool. I think the verification of the AI chips is definitely a very new and challenging area. I hope some audience, maybe students, PhD students from the audience can work on this part. We need new ideas and new technology to solve the problem in the future. So the next, as we can see that the AI chips is actually growing very fast, and even growing into an AI systems, and also including the operating system and embedded software, etc. So I think the challenge for verifying the AI system or AI chip is increasing. So what would be the challenges of opportunity you will see in the future for the development of the formal engineering on AI verification, AI chip verification? You want to share some of your perspective?
I can share. So I think you had a good slide up there which triggered my thought on this too. It was your slide about edge versus cloud and the whole spectrum there. And each one of those has sort of different requirements, right? And so it got me thinking. I remember when I started at Verplex many years ago, I remember one of the early years of going to DAC and seeing all sorts of things around System C and high-level synthesis. And I was worried at the time as an RTL person, is this going to take over the world? And it hasn't. It certainly has a role to play. But I think as you look at these, what's happening and how System C and that whole high-level synthesis flow really can be another facilitator of AI and ML, but in conjunction, when you want to look at these different scenarios and these different designs that you need to implement, having one level of System C and being able to generate different RTLs for different requirements, maybe this comes back into play. Maybe this is another aspect that's important for AI, especially System C is great for algorithms and this, maybe less so for control logic. So I think is System C really going to take off a little more in the high-level synthesis that give people this knob to turn, this is a type of architecture I want for this versus that, and be able to quickly create different architectures for these things through a high-level synthesis. And so I think this is an area that we'll see a need for more formal verification. If this area is really to take off in System C even faster than it is today because of AI and AI chip design, then there needs to be formal solutions around System C. Everything from you're doing high-level synthesis, you need to do equivalency checking, much like you do for RTL. You want to do FPV and RTL, you probably want to do that in System C. Can I write properties about my System C and formally prove it? Can we do things that we do in like our RTL and auto-generate properties today just from structure, not even with AI and ML? Can we do this in System C and target and run formal? So I think maybe this will be one of the things that will come out of this, is that System C will give people this ability to also be super productive in generating these different architectures that are needed. And then we need to bring the formal tools along with it to facilitate and enable that as well.
Yeah. Yeah, I think I want to follow Chris' comment about the high-level synthesis. I think as we can see in the software side, more and more people are using natural language to write the program. Okay, like using the Gen AI, tell the Gen AI what's the kind of describe the spec of your software, and then the Gen AI will create the software for your website or your app. So people usually are wondering, is that kind of design bug-prone or is it more bug-free? I think that's an interesting question. But personally, I see actually the AI generated program is actually better than, I would say, 75% of the code that people write. So it's actually more robust. So I think from the hardware side, it will be also interesting to see that can high-level synthesis move to like natural language or some sort of technology like that using the Gen AI. Yeah, so yeah, I think that's possible. So maybe Sandeep or Chilai want to also.
In terms of, again, like the challenges and the opportunities, as I was mentioning, formal in AI space is an emerging area, as ML models tend to be like highly opaque and inherently nonlinear. So I can think of broadly like 2 or 3 different schools of thoughts over here. Like say the use of safety shields, which can ungate unsafe behavior from the ML model using hard constraints. Then application of formal engineering to verify the ML models, like the deep neural networks. And this scales to a certain extent using semilinear activation functions. And then like using safety constraints while the training of the model is going on, which also ensures to a large extent that the learned model is safe. But application of formal engineering in this area is still, to a certain extent, outside the purview of EDA domains, but probably I think EDA might catch up soon to cover this as well in the future.
Yeah, I think we would like to see if the progress is coming to to the market soon. Yeah. So Chile want to answer this question?
Well, now we are really talking more about the new architecture there, right? Because currently it's always say multi-core, then you somehow then figure the thing there. But I know some of the stuff they are investigate how to kind of put the memory together with the computing there, much tighter. Now, currently, of course, people are using HBM. That's almost as a way there. So hopefully there will be a new architecture there that will maybe better suited for some of the AI application. Rather than right now it's one size fits all.
Yeah. I think the today I learned a lot of opportunity for the future research, either on AI for formal or formal for AI. But so I think before we conclude this panel discussion, I would like to open 1 or 2 questions from the audience. Does anyone want to raise a question or want to comment on our sharing? Anyone? Yeah, thank you. Please.
Yes. I think I have a question about, do you have any suggestion for DV and the design engineers? How should we prepare? I mean, maybe do what kind of human learning before we apply machine learning on formal verification? Yeah, thank you.
Well, that's a very good question. I believe many of you are design engineers. How many of you are design engineers? No? Yeah, but I think that's very important to share how the design engineer prepare for the new era. So, Chris, want to go first?
Hopefully this answers your question. I think it was another slide that you had about collaboration. That was one of the elements you had. So I think it goes to, you know, closely collaborating on what the problem statements that you have with your vendor and trying to map what's feasible today in these technologies with your problem statement. So I think it comes down to that. The collaboration has to be close so that we're matching a problem statement with what's feasible. I think there's as I mentioned earlier, there's a ton of false expectation, and things will improve and things will get better, but we very much have to collaborate to crawl, walk, run, to really solve important problems that can be solved today. So it's not like it's you do your thing, we do our thing. It's really together. We have to work and figure out what that marrying of the problem and the capability is today.
Maybe I will also like to add a couple of points over there. So I think being able to identify the right set of problem statements and to be able to break it down and identifying what solution to apply over there also goes a long way to ensure that this collaboration is successful. For example, I think there was a question over there that formal is generally like supposed to work on block level. What happens when formal is applied at the SOC level? So these are some of the questions which we also get asked, and we see because of virtue of this democratizing FV to civil engineers, like many times they're sending the entire SOC to like a FPV based problem, right? And then the formal kind of like chokes. So to be able to identify the right set of design and the right set of environment is also very, very crucial. So yeah, I think there the design companies, the verification engineers and the EDA vendors need to collaborate to identify what is the right place to use formal for.
So should I? Yeah, I want to add one more recommendation. So I think for the verification engineer, do not afraid of using or adapting new tools. I think there are many good tools and technology out there, but many of you are too used to your existing methodology. So do not afraid using new tool. Okay, try the new things. And also, you can spend some time on like some forum like Twitter, X, or like Reddit. I think there are many interesting discussion there. So follow some of the discussion, and you'll get to know the new trend and new technology. I think that's very important for the new generation here.
Yeah, I think the other thing is, you know, I'm not an ML or AI expert, but I am curious. So I would encourage everyone to be curious. Go try and take natural language and see what it'll produce. That'll also kind of gauge your level set where you're at too. But I encourage everyone to be curious. We're engineers, and you know, go play with this stuff. It's interesting.
Let me reveal a secret. My son, actually, when he took the hardware design course, he's a software guy. He doesn't like hardware. So he actually used Gen AI tool to write a Verilog program for him. And he got A+. So try it. You'll be very surprised. Okay. So there another question here?
I have one question about the different types of application. First of all, I'm the VSO.ai user, and in many companies, we evaluate the productivity for the, we call it the 90% nice to have the selection. For example, the orchestration selection, the constraint random solver selection, it is productive and with the measurable enhancement after applying machine learning. However, on the other angle, as for even the simplest TCL or Makefile or even a C shell command, we are not able to use AI as nature as in the EDA tool, such as the SVA generation. SVA generation, even by ChatGPT, is somehow reliable. But for the very fundamental and easy script, but we need 100% accurate, it's the gap we observe in our daily engineering life. So I want to ask about how can we imagine, or the landscape, or what's the foresee for the 100% engineering scripts to be enhanced by AI, the fundamental and the easy stuff. Thanks so much.
I mean, Cindy, you should answer first.
I think, thanks for providing the feedback. Definitely, it's very interesting. Although I hope that it doesn't take away the job from the verification engineers, right, who are tuned to write this kind of scripts. But definitely, this is one area where people are investing because some of these things are probably like very easy to automate in that sense. And otherwise, I mean, what ends up happening is engineers or groups which tend to move to a new design or a new project, right? They tend to copy existing scripts from a previous project, and many legacy things end up happening over there, which have like fallen short with respect to the new versions of the tool, and that causes problem. And we have seen that. So if the tool can automatically figure this out and generate the right set of scripts with respect to the right set of version, I think that will go definitely like a long way. So we are not exactly investing in this area, but point well taken and feedback well taken.
Yeah. So any other?
No, I was taking your as feedback, as less of a question. I also agree this is painful, and coming from, you know, I can speak to Jasper. Jasper's like TCL API is you know, is fantastic. It was one of the best things about Jasper, but it's so sophisticated and complicated. How do you navigate it, and how do you do productive things with it? So this is an important area also for us to, you know, use AI to make it easier for people to do these sort of things, more describe in natural language what their intent is to do with a tool. So this is also things we're looking at. I think, again, it's about, we're still trying to do level setting on, you know, so a particular LLM isn't going to know the Jasper commands. They're not trained on them today. But, you know, do we have to get into training models to do this appropriately, or can we use other techniques? There's many techniques to augment LLMs, retrieval, augmented generation, and these things that can provide capabilities. So we're absolutely looking into these things, and we acknowledge this is one of those high-value problems that if we can solve, will make people, it'll be easier to use the tools and pass things off to other users because it'll be more natural language and things like this. So it's an acknowledgement, and it is an area we're particularly interested in looking in, for sure.
Yeah, in some way you can look at like Excel. You know, in Excel, it's a very easy one, but some of the formulas are very complicated.
Yes.
And I know like Microsoft, they are making lots of progress also. They have some kind of like things. So you show them how you want to generate one. Not writing the code, the formula. Then they will generate formula. So it's interesting because I use once. You know, lots of those complex formulas, you learn how to do it once, but then next time you want to use it, you forget. Now you need to search for and say how to do it there. So like all this, you can see those are minor things, but unfortunately, AI, lots of times, they cannot handle those minor things. Because those minor things require lots of the expert knowledge there. That's a part. Personally, I think, you know, right now, because people are all focused on the generative one, which in some sense, we need the people to really working about this other part. We need to be precise, That's the key part. Rather, AI has very imprecise. There's lots of hallucination. They can invent something out of blue there, which I don't think nobody feel comfortable.
Yeah, I think the improving should be coming very soon. So, any other question from the audience? If not, I would like to ask for your some concluding remark with regard to this session. You want to share some thoughts about this?
Sure, I'll start. I think this is an area that we're all extremely interested in. We're all up here investing in it. I think it can do a lot to, as I said, further democratize formal. We want to get it into more people's hands. We're hearing from the customers. We want it in more people's hands. So we absolutely need to embrace this technology to do that and get it into more people's hands and make people more productive and make difficult problems informal, like performance and the things Eric was talking about, decomposing a property and creating invariants and these things. We need to make all of those things easier and hopefully use this technology. But that's in collaboration with you, the customers, to have the right problems and the right expectations. I would say that's where we're at, and we'll work closely together to do that.
Okay, cool. So, Eli?
Well, okay, because we are still investigating how to kind of put our knowledge into the AI. So this is a part that we are putting lots of effort right now. For example, like in the VIP there, we have like 40 or 50 VIP there. So we have lots of information about the spec, about the BFN, about the test case. But currently, how do we train those things there? The interesting problem. So that part we will be working on. Hopefully in a year or two, we can more definitely answer there.
Yeah, so, Sandeep, want to conclude?
Right. I think I'll absolutely concur with whatever July and Chris has said so far. So yeah, I think this is one area where, from the Synopsys side, we are heavily investing in different facets to be able to apply AI and ML to verification, to design, and everything. And definitely, I think we look forward for feedback from our customers. I mean, who can share the right set of problems where they want this technology to be applied, right? I think that gives us precise information to understand what is the area where we need to innovate in the future. But as I already said, I think this is one area which is making like a lot of inroads, and I think this is expected to grow even more in the coming days.
Sure, sure. So I think as a user and researcher in this area, I would also like to encourage everyone to use more on this AI power tool and use one more tool to verify AI chip design. I think as we use more and more on this direction, there will be more data for them to train their model and get a good experience about what's the best way to collaborate AI and formal engineering. Okay, so let's take a moment to give a big applause to our established panelists, Sandeep, Chilai, and Chris. And I hope you enjoyed the panel, and let's see what we can do in the future. Okay, thank you.